Hello friends. Now in today's session I'm going to discuss with you about static data. First of all, we need to understand about static storage class and its features. We know that while studying storage classes we understand about the features of static storage class. Then we need to discuss this static features in the reference of OOP. That's why we need to discuss about static data members and static member functions. Yes, we know that up till now that there is a static variable. Now what is the property of static? It retains its updated values in the next new occurrences. It retains its updated values in the next new occurrences. That was the feature of, let's say, feature of static. It retains its updated values in the next new occurrences. You have to prove this. Second, it initialized by default to 0 and having scope where it is defined. Okay, so means static retains its updated values in the next new occurrences. That we need to prove firstly. Means it holds the values right in the new occurrences, and then we'll go to the static data members and static member functions. Let us demonstrate this using code now. Demonstrating static variable. I'll be writing a C++ code. iostream.h, conio.h, io manip.h. Let us declare a function. Let's say, for example, void f1 and void. Okay, we're writing a code to elaborate to get the features of static variables. Let's say if I write a function called as f1 and I'm having a loop over here, integer I equals to 1, I less than equals to 5, I plus plus, let's say. This 5 times I'm giving a call to function called as f1, and here is the function definition, right? And void f1 void is a prototype of this function. And let us understand, here in the f1 definitions I declare a variable called as x, right, and value 5. And if I say cout, the value of x and NL. Now what I did, I am having a function called as f1, and I refer that function for 5 times from the main. Every time the control will transfer to f1. F1 have a local x. Right now this variable is declared as a local x, and if I print a value of x, now it is obvious that first time it will print the value 5 and again return back. Second time 5 5 5 5. This is what output we are expecting. Now if I say here, means it will print 5 for 5 times, but if I say x plus plus after printing it, okay, then what will happen? So again x equals to 1, I equals to 1, so it will give a call to x become 5, print 5, x plus means now it becomes 6. But whenever you give a call to another call to f1, right, as this x is local to f1, so again it will get initialized to 5. Means if I run this code again I will get 5 times 5, because that updated value of x will not carry on, because you are giving a call to main from main, and the function definition is outside main. So the scope of x is lies in the function definitions. So whatever number of repeatedly you are giving a call and update that value of x, that will not be reflected to the main. So 5 times whenever you are referring that particular functions, it gives the same value 5 5, though you are updating by 1 every time. Let us run this code and check the output firstly. Let's say I'm saving static 1.cpp and reload that code. Static 1.cpp, here it is, run it. You'll get the answer x5 y x5 x5 5 5 for 5 times, as we just recently discussed. What it proves, though you update the value of x outside the main, outside the scope, that updated value will not be reflect back, or rather it will, if it is a local variable, it will not retain its updated values. It will not retain its updated value in the next new occurrences, right? Now just replace this by static, then we can understand the feature of static. If I replace this by static, then what we just recently discussed, what is the feature of static? It retains, it holds its updated values in the next new occurrences. Means when first time it gives a call, it will get initialized to 5. As we know that static get initialized to 0 by default, but now as we initialize it by 5, it get initialized by 5 by default. So whenever first time if you give a call, x is become 5, it prints 5. But whenever you are updating that value of x plus plus in the next new occurrences, means second time whenever you give a call to, it will not reinitialize again. It will hold its updated values. Means next time it will not initialize by 5, it will initialize by 6. Right? So in that local block, whatever the updates you will do with x, every time the updated value will be referred. Is it clear? So now the answer we are expecting that initially 5 6 7 8 9 5 6 7, this like 5, initially it was, earlier it was non-static and it was printing 5 times 5, but now we are expecting, as we update to the static one, right, it will hold the updated copy, and what is the updated copy means? Every time whenever we are referring it, it will update it by 1. So 5 initially, then 6, 7, 8, 9. That is the answer we are expecting. Let us try this firstly. Let us check whether we can. Static. Let's check whether the updates comes over here or not. No updates are there. Okay, so we'll updates. Till there is no updates. So updates means that the code updates what we read over here, static. No issues, we can reload it again. Okay, now we got the updates and run it. Updated copy of your code, and here you get the answer. X is 5, 6, 7, 8, 9. Earlier, when it was non-static, it was not updating its copy. It will hold it every time. It will create a new copy of that local variable, and it will print the value 5, 5, 5, 5, 5 for 5 times. But now, as X becomes static, so every time it holds its updated copy. It retains, holds in a sense, it retains its updated copy in the next new occurrences. So in this manner, we prove the point that static holds its updated copy in the next new occurrences. To understand this clear, things very clear, means the difference between static and non-static. Non-static means every time whenever you refer, its new copy, not updated one, its new copy will be assigned, and in the static, it retains its updated copies in the next new occurrences. Let us understand this thing in a different example. If one person having name ABC and having age 5, right? Having name ABC and having age 5. Now, he is having scope in a, he is living in a scope means he is living his own town. Now, after every year, he is going to visit to another place. Okay, maybe this is A city, and he every year he goes to the B city for vacations, maybe every year. So whenever ABC having age 5, when he visit to year number 1, when he visit to a B place, what is his name? ABC. What is his age? 5. And he come back. Whenever he go to the same place next year, what is his name? ABC. What is his age? 6. Third year, ABC name, age 7. Fourth year, ABC name, age 8, and so on, 9 in the next year. Now just understand, what is ABC's name? Is that name change? No, name remains same. It remains unupdated every year. It means it is non-static, and his age is going to change every year, so hence it is static. The reason is it holds its updated values in the next new occurrences. Means in the B, considering B place, in the B place, ABC 5, 5 is age, ABC 6, ABC 7, means ABC is a non-static, and yeah, your age is static. Now in general, static means we said static is non-change, not like that. Static is a variable. Variable means, just we need to understand one point, right? No, most of the time we people will make a confusion. Static means non-change. No, you're wrong. A variable which is not changeable, that is called the constant variable. Constant variable will, once it assigns its value, will not be changed. There is a difference between constant variable and the static variable. Most of the time we make a we have issues. We define static as a, okay, static means non-change. No, you're wrong. Static means it holds its updated values in the next new occurrences. And what is constant means? Once you assign the value, it will never change. That is constant. So there is a difference between the constant and the static. Static means it holds its updated values in the next new occurrences. Hope you understand by the example of that name and age. Here name is non-static, age is static. So every time you refer to the next place, your age is going to change, but name will remain the same. So now what we studied about the static features, it holds its updated values in the next new occurrences. Point number 1. If you not initialize to any values, by default it will initialize to 0. So if you run this code now, it will x is 0, then 1, and likewise. Means it will, if you not initialize any values, then it will initialize to 0. That is what the property. You get it clear? So this is how we can just again run it if you need. To prove that static variable get initialized by 0 by default. Here it is, x is 0, x is 1. Now if it is non-static variable, then you know one thing, the local variables will get initialized to the garbage value. It will not get initialized to 0. But static variables have a property, it get initialized to 0 by default. Second, it is having scope wherever you declare, whether it's a main scope or the function definition scope or a global scope. It retains its updated values in the next new occurrences. And that is what the feature of a static variable. Okay, let us discuss it by in the OOP reference now, right? Now we'll define as a static data member. Let us say class test static. I'm writing, and here I will write the two data members, int x and static int y, and here is the public. And here let's say get data, . rather we'll do one thing for the sake of understanding. Will be even declare this data members also as a public, so that we can, by object reference, I'm just like going to help you out why I'm writing it, and I'll define a function called as show data, where I will print the copy of cout, the copy of x, and the copy of y. I'm just trying to explain you the how if a static is a data member, how it will behave, and what is the difference between non-static data member. We discuss about static variable now, static variable in the structure-oriented programming reference. Now let us understand static data member in the object-oriented reference over there. So I just like declare two public data members x and y, where x is non-static, and y is static, right? If you have a static data member inside class, then as we know that static data member or static variable get initialized by 0 by default, and initialization of data in a class is not allowed, right? Initialization of data in a class is not allowed. You can't write static integer y equal to 0 or x equals to. That's why if you have a static data member outside the class definitions, you need to initialize it like this: int in the test static scope, there is a y, and initialize to 0. That's it. If you need, if you can initialize to any values, but like why this is needed? Because initialization of data members is not allowed inside class, and by default static have a property that it get initialized to 0. So you need to tell the compiler that I'm having a static member available as a data member inside class, so let it get initialized to 0, sort of. And then you can initialize to any other values also. Then you go to the main. I'll explain each and everything why these steps I'm taking over. Right? Clear the screen and create an object. Let's say TS is the object I created. If something is public, something is publicly defined, I already explained that data member should not be publicly declared because object can directly access it. But here I am declaring it public because I want to demonstrate it how static and non-static will behave with the object reference over there. So it's not a case of a data security at all right now. That's why I'm declaring as a public. So here is the first object, test static ts1. Right? This ts1 object having copy of x equals to, let us say, 10, and ts1 having copy y equals to also 10. Okay, means first object of test static having x value is 10 and y value is 10. Then if I say test static ts2, I create the object ts2. Okay, second object, and then ts2 dot x equals to 50 and ts2 dot y equals to also 50, and then I will create a third object. You can create n number of objects of any class. That's what the call. So test static ts3, and now let us say 60 and 60. So we have a public data inside class as a x and y, but x is static and y is non-static. Sorry, x is non-static and y is static. So here, as y is static, so I initialize this to 0 inside class definitions. I explain you why what is the purpose of it. The reason is, by default static get initialized to 0, so you have to tell the compiler that, and static data members are not supposed to initialize. That's why you have to tell the compiler that as it is static, I am going to initialize to 0. Then I create the three objects ts1, ts2, ts3. Now you know that every object having its own individual copy. So ts1 dot x equal to 10, ts dot y equal to 10, ts dot y equals to 50, ts dot x equal to 50 and y equal to 50, ts3 dot x equal to 60 and ts3 dot. So I'll explain you what is the purpose of it. Then what I will do, I'll give a call to ts1, okay, print copies of object. Let's say ts1 dot show data, ts1 dot show data, then ts2 dot show data and ts3 dot show data. Then you'll say what's the output you're getting over there, because ts1 having 10 10 x and y, 50 50 and 60 60. So what the output you are expecting, ts1 dot show data, x is 10 y is 10, ts2 dot show data, x is 50 y is 50, ts3 dot show data, x is 60 y is 60. Hope you are expecting the answer. If the answer is like this, it becomes very simple, but no, it is not like that, right? So the expected output will be, in the first case, ts1 dot show data, x is 10 y is 10, right? In the ts2 dot show data, x is 50 y is 50, ts3 dot show data, x is again x is again 60 and y is 60. That is correct. But now if you initially, if you're doing in a sequence, but after this, if you print now, what you will get it? You will get it over here when you initially you print it, okay, 10 10, 50 50, 60 60, right? But whenever you print it over here, right, now here also you will get it. Okay, okay, firstly not okay, we'll test it over there, because your first time ts2 show data, okay, so it will print 10 and 60. Here it will print 50 and 60. Here it will print 60 and 60, right? So hope you understand. Means basically, whenever initially the ts1 is object, whenever it initializes to 10 10, it's okay, but whenever means your non-static data have an individual copy, right? So ts1 dot x will 10 and ts1 dot y will 10, but whenever you update that copy with the ts2, it become 50 and 60. So latest updated copy of y static, that is 60. So ts1 dot show data, x is not updated because x is non-static, right? So it got an individual copy, so 10 and 60. Why 60? Because the copy of y is updated by ts3, right? So static means in case of object reference, all the objects will share the common copy. All the means ts1, ts2 and ts3, all the objects are share a common copy of static. And in case of non-static, every object have a individual copy. In this manner, in the object-oriented programming reference, static will retain its updated values in the next new occurrences. First occurrence of y is 10, second occurrence of y is 50, third occurrence of y is 60. Who updated? Different individual objects. But as that data member and that all the objects are belong to the same class called as test static. So in case of static data members, updated copy will be referred. So initially ts1 updated to 10, ts2 then updated to 50 and ts3 then update to 60. In case of non-static reference, they have the updated copies will not be passed on, right? They earlier said, okay, the name was non-static, so updated copy will not be passed on. Age is static, so updated copy will be passed on. So last update with the y is 60, so that's why it will print 10 60, 50 60 and 60 60. Let's check the output. Okay, static2 dot cpp and reload it. Okay, just run it. I will be spelling everything. Test static. There was a spelling error, so I should have corrected it. Get the output now. X is 10, y is 60, right? X is 60, y is 60, and x is, oh, this way. Why it's happened? No. Just check it out, the code again. Here is like static y and the okay public data over there. Fine. X is 10, y is 10. t2 dot x equals to 50. We are not adding it. t2 dot x equals to 50. Okay, so static is what? Y. Okay. So what the output we get? Let's check it out, the output. 32. X is 10, y is 60, that is correct. X is 10, y is 60. But now ts2 dot x is 50 and ts2 dot y is again 50. So ts1 dot show data, x is 10, y is 60, that is correct. But here in this case, ts2 dot show data, x is 50, ts2 dot x. Yeah, and here we are not updated. Yes, equal to it, we are not adding it. Let us check it out. Why it happened? Because he is adding it. So y become 60, 60, 60, that is perfect. But if the copy of x is adding, that is not correct actually. Because every object have an individual copy. ts2 dot show data. So x initially is non-static. So it's a 10, 10, 50, 50 and 60, 60. That is what I was expecting over here. ts2 dot show data and ts3 dot show data. So here once you run it, there we understand that the copy of non-static, right, is up, like, okay, static means it remains, okay, in the next last update was with a with a t3 object and update to 60, so it will pass on that update copy to t1, t2 and t3. But look at the x, first it was 10, second is was 60, and the third update 50, and so 10 plus 50, and then we added 60 plus again 60. But 1044 is the wrong answer. I believe there is like something, okay, I need to correct it over there. But like, okay, I need to okay, what the things are there, why it is happening. Let us check it out. Test static x and y, see out the value of x and the value of y, and static x equals to y equal to 0, and then here ts1 dot x equals to 10, y equal to ts2 dot y equals to 50, okay, and test static ts3, third object we created over there, and then 60, 60. My compiler is giving the wrong answer. The reason is it should give the answer 10, 60, 50, 60 and 60, 60 over there, right? So we'll again discuss it in the later sessions, okay. So we need to understand one point, that is static means it holds its updated, and it proves that particular point that static will hold the updated values in the next new occurrences, okay. And non-static means it will have its individual copy of it. So the output of this particular code has to be the 10, 60, 50, 60 and 60, 60. It, like, computer is giving a bit wrong answer over there. We'll check it out what exactly why it is showing that same, right? Okay, now let us understand this, why we are getting what we discussed up till now. We discuss about the static variables. It is created at the start of the program executions, means like, okay, it's updated just like in the initial stage what we discussed. Whenever you compile, whenever we add a static variable, by default it get initialized to 0, right? And then whenever you start the programs, it get initialized automatically, and then Static variable have a scope of local variable, means like whenever you declare, if you declare a static variable inside function definitions or the main or the global, that is your it will remain its own scope. But it has lifetime of a global variables, because as it has to carry the data throughout the updated copy, so it is having a scope of a global variable. Therefore, static variable retain their contents or the values until the program ends. As we are discussing, it's like, okay, it is having a property that it holds its updated values in the next new occurrences, and that is what actually the static variable means. If it is not initialized, if you not initialize to value, it is get initialized to 0 automatically by the compiler, right? So static is resembling something like a global variable, but the global variable is different. It got the scope in a global space, but here it is having a scope in anywhere else, means in the function definitions main, right? And the main feature of a static variable, that is it holds its updated values in the next new occurrences, and it get initialized to 0, right? Static members, if you have a static member, then static variables shared by all objects, as we just recently discussed, all objects will share the common. What we need to study about the static data members, we'll be discussing with more programs again, okay? Because initially in the first program we get some different output over there, but like here in this case, as per the expression, output was not there, so we'll discuss more programs. But static variables will shared by static variables copy, okay? Basically, let's say you have a 3 members, and we got a 3 objects. So every objects have an individual copy, that is non-static, and static means all objects will share a common copy. Let us understand by example that if in one family there are 3 brothers, so family is a class and 3 brothers are the objects, and if they have a individual bank accounts, if they have a B, C, these 3 objects have individual bank accounts, means like, so whatever the credit and debit they will do, whatever the deposits and withdrawal they will do, it will not reflect to, means like A's money will not reflect to B and B's money will not reflect to C. But if you have a common account, if these 3 brothers have a common family account, so if A updates something, so that will goes to B, and B updates, if A deposits 1000, so that B and C will share will get the copy of 1000 over there, and if B withdraws 500, so updated copy will be passed on to A and C. Hope you understand by this example. So static means all objects will share the common copy of it, right? And non-static means all objects having their individual copies. Static functions, we'll discuss about that, have access to static members only. Static members can be accessed by the class name. Static members can be, means like, if you are as static means all objects will share the common copy. So one can say that static means not a copy of an object, it's a copy of as I said about the family is a class, it's a family account. Static is a class type of data member, not an object type of data member, because object have an individual copy, right? So though we are referring by the object reference, so here let us update that code firstly, so that we'll if you say, instead of object reference, if you say static, we can even refer by the class reference as well. Let us check it out. Can be referred by the class reference. Yes, it is possible for us to refer by the class reference as well. So static members, why is the static? So static members can be referred by the class reference as well. If you try to refer the non-static reference, it will give the error, right? Fine. Then about the static data member, a type of data member that is shared among all the objects of a class known as static data member, that we just recently discussed. that if you have a static data member, all objects will share the common copy of it, and if you have a non-static data member, every object having their own individual copies. Static data member is defined inside class static keyword. When the data member is defined static, one variable is created in the memory, and then many objects will share the same. Okay, one variable and many references of it. A static data item is useful for the objects of the same class must share a common item of information. The characteristics of static data member are the same as normal static variable that we just discuss about it, right? Here it is. If there is a if there are the objects, okay, if there are these are the objects of a cube class, so all objects have their individual copies, okay, of non-static, but every object have a common copy of static over there. Static data members, all objects will share the common copy of it, right? So if one updates, that update value will be passed on to others. Like initially it was 10, 50 and 60. So whenever we find to refer it over there, then what we observe that the updated copy will be passed on to all three objects. Means all like let us say considering the example of a family and the three brothers they are having. If A updates to 1000, that their account, and if B update to 10,000, and then and C update to again 10,000. So 1000 plus 10,000, okay, 10,000, 11,000 over there, and then again 21,000 over there. So the if A is going to go to again to the bank and then check his account, family account I'm saying, then it become a 21,000. But in case of non-static members, if A updates with 1,000, so B will get 0, C will get 0, because obviously it's not a common account. And if B updates his account by 10,000, doesn't mean that okay, the updated copy of like 11,000 will be passed on to A and C over there. Hope you understand this. Static data members, it is normally used to maintain common values in the entire class. Okay, common values, common to all. Static means common to all, and non-static means every have the individuals. Let us the examples like okay, the public like transportations and the private cars. Okay, so it can be used to count the records of all the objects. Static members associate the class with it is actually associated with the class, not with the object, but it is shared all the objects of a class, right? And it may exist if no objects of the class is right. Obviously you can refer it by the class name. Initialize to 0 when first object is of the class is getting by default, as I just explained you. Okay, if there is a static member, you need to initialize like this. Okay, so whenever or if you not initialize also, so whenever the object is created, automatically it get initialized to 0. And here again all objects will share the common copy of the static member over there, right? So let us discuss this by another example. Okay, I'll open it. Yeah. Here is the class item, and in the item class we have a count as a static data member, and number as a non-static member over there. Whenever you give a call to the get data, the value of that particular value will be passed on to the A as a value as an argument, and that value will be initialized to number. So whenever you create the object, okay, and give a call to the get data, so the copy of A will be passed on, and count will increase one by one. Count will increase by 1. So number is a non-static, so it is having individual copy of it, and your count is your a static one. So it get initialized to 0 initially, right? So it increment by 1 whenever you give a call to the get data, and get count will print the value of count, right? How many counts are there, right? So and then here initially we are declaring a static. As count is a static, you have to initialize it. So let us say by default count is 100. Counting is 100 by default, means whenever you initialize run this program, the count is 100. Now 3 objects we created, item A, B, C. Just understand one point, that you got a count is a static and number is a non-static. So initially A, B, C. Okay, if you say A dot get count, we are printing the value of count. Initially by default it is 100, so it will print 100, 100 and 100. Then you said you are using A dot get data 100, B dot get data 200, and C dot get data 300. Now A dot get data 100. So the copy of number become 100, then 200 and 300. But every time in the get data you are incrementing by 1. So earlier the copy of count is 100, 100 and 100. Then whenever you call a get data, it becomes 101, 102, 103. Okay, and after that if you print it, the value of get count, you'll find it's like 103, 103 and 103, because whenever you give call to see like okay get data lastly, so the copy of the count was increment to 103, and then if you print it, okay, let us refer this code over here. Static and load it. And just run it. Before running, let us say what output you will get it over here. Expected output. Here count is initialized to 0. Count is a static type of variables. So a get count means obviously it will print the value of 100, 100 and 100. And then whenever you give a call to the get data, A dot get data 100. So number become 100, but the count is incremented by 1, so it become 101 over here. So it will print here 101, 102, 103, and whenever you print the get count, it has to print 103, 103, 103. The output we are expecting that is 100, 100 and 100, and then 103, 103 and 103. Okay, let us try it. We are trying to prove that the static will hold its updated values in the next new occurrences. It means in case of object references, every object will share the common copy. If one object, that updated copy will be passed on to the next object. Static 3, yes it is. Fine. Here it is. Count is 100, 100, 100, and after, because a dot get data, so though the different value will be passed on, but the counter value will be incremented one by one. So every object, whether A, B, C, item class got the 3 objects A, B, C, but every object will share the common copy of static. So hence it is initially it is 100, 100 and 100 by default it increment, but whenever you give a call to the getter, though you update that values, so update that value of a number, so everyone have a new value of a number, but the static data member, that is called the count, it holds its updated value, and hence it is printing 103, 103 and 103. So I'm just sharing these all the codes what I'm testing to you, so that you can also test it, and then we analyze. Okay, and then we need to understand what is the how the static data members will be behaved, right? And whenever there is object reference, means like one point, if it is a non-static data member, every object have an individual copy, and whenever there is a static data member, every object have a common copy. Just understand the example of a 3 brothers have a common family account, and the 3 brothers having a individual for bank accounts. Individual bank accounts means if they, whatever the credits and debits they will do with the individual accounts, they will not reflect it to their accounts, to others accounts over that. But like if there is a static, means a family account over there, so ABC can access, as they are the family members, they can access their accounts. But like if one updates of one by one object will reflect to the others as well. That is the static and non-static. So this example is the best to understand the difference between the static data members and the non-static data. Right? Let us go for another example. Now we need to discuss about one thing, that is static member functions. We discuss about the static data members. All objects will share a common copy of it. So one object's updated copy will be passed on to another. In this manner, updated copy will be referred in next new occurrence. Means in case of object-oriented programming, how that updated copy will be passed on to the next new occurrences, obviously. So all objects will share the common copy, so updated copy of the static variable will be passed on to the next object over there. Now we discuss about the static member functions. So can member functions can be declared as a static void f1, and what is the purpose of it? So when discussing about static member functions, yes, member functions also can be static, but why we define static? Why static functions? Because you don't have a copy, so why static functions? It's not data member. One, it can be referred by class name. Second, it can access and process only static data members. Means mostly static members are defined to process static data. If you have a static data, static, as I said, static belongs to class, not static belongs to object. So if there is a static data member, if you want to process by class name, you can process it. So updated copy will be passed on to it, to all the objects over there. Static function, okay, static functions purpose is to process the static data, and static functions can be referred by class name as well. So this is what class name only, okay, because it not belong to object, it belong to class. So let us discuss it by example. Then up till now we discussed about the static variable, static data member, but can static, there is a static member function as well. Yes, static data member functions also can be defined, but what is the purpose of it? To prefer it by the class name, and second, to process the static data members, right? Static data members can be processed by object reference as well, but like as you know, objects don't have this own individual copy. Say it's like a common copy they are sharing. So if you want to process the static data members, you can use class reference also, right? And static member functions are actually defined for processing the static data. Okay, let us go for one more example of it. Yes, here it is. Static member function. We have a code as a private data, and like non-static data member, and count is a static data member. Set code, right? Whenever you give a call to the set code, count plus plus, as you know that by default it get initialized to 0, so it will increment it, incremented value of count will be assigned to code. And show code, you are printing the value of code. Code is non-static, so all object having individual copy. And show count, static. Show count is a static member function, so it will print the value of count, right? and every time every time if you are giving a call to the count, you are pre-incrementing it by 1. Let us understand this. Now here, as I said, if you have a static data members, you have to declare it outside the class, because static data member have a, by default it will get initialized to 0. So you have to tell the compiler that I'm having a static data member inside the class, and by default it get initialized to 0, so the value will be 0 over there. Then you got a void main test t1 t2. You create the two objects of test, right? t1 and t2. t1 dot set code. t1 dot set code, as I said, count value is 0. Whenever you give call to the set code, okay, 1 plus like it will perform the right hand side firstly, means count become 1 and code will become 1, right? And t2 dot set code. t2 dot set code means now the value of count is actually 2, and then it become code become 2. So t1 have a value 1 and t2 having value 2 of a count, right? t1 dot code is 1, t1 dot code is 1, and t2 dot code is 2. So but if you print the show count, test dot show count, obviously it has to print 2, because initially it was 0, and t1 updates to 1 and t2 updates to 2. So show count value will be, the value of count is 2. Then we have created t3 and t3 dot show code. Now the value of t3 dot code is 3, and show count will be again 3, so it will print 3 over there, right? So initially it will print 2, and then it will print show count 3. Then t1 dot show code. Now show code means obviously t1 having its individual copies, it will print 1, 2 and 3. So the output I am expecting, that is here show count will 2, show count will 3, the value of count is 2 and value of count 3, and whenever you print the show code, it will print 1, 2 and 3. Let us check the output. Yes, count value is 2, then count value is 3, and then because we are referring by the by the class name, okay, and then you are updating the value, and the object number is 1, 2 and 3. Means here it proves that here the value of code is non-static, so it is not updated. So every copy of t1 and t2 having its own respective copy, t1, t2 and t3 having their individual copy. But whenever you are referring to the here I'm demonstrating that how to give a call to the static function show count. Show count is a static function, right? So you can refer static functions can be referred by class name. So class name scope resolution show count. So in this manner we can give a call to static function. Static member function. As we just discussed that static members can be exist. Okay, it is possible to write the static member functions. What is the purpose of static member function? It can process the static data. Here it is processing the static data, and it can be referred by the class name, class reference over there, because your static not belong to object, static belongs to class, right? So here whenever we write the set code, so the updated copy of count will be passed on to t1 and t2 and t3, but t1 and t2 and t3 having individual copy of code, but the common copy of your count over there. So this is how we discuss about the static. Let us recollect it, what we discussed up till now. Static variable have a feature that it holds its updated value the next new occurrences. I explain you by the giving example that f1 is a functions. There I write a non-static, so 555, and whenever you write a static, it's updated copy will pass on. Then we come to the like, okay, object-related reference over there. If you have a static member and non-static members, non-static member means every object have an individual copy, and static means every object will share the common copy of it, right? So static means belongs to, I had given you the example of three brothers have a family account and three brothers having individual account. That is the best example, I believe, to understand the static. So static means common in all objects will share the common copy. It belongs to class rather than it belongs to object. And if you have a static member functions, yes, you have a static member functions, but like static member functions mostly can be defined to process the static data. It cannot process the non-static data, and static member functions can be accessed by class reference, and obviously it will share the updated copy of all the objects will share the updated copy of it. So this is about the static storage class and static members and static member functions. Hope you enjoy this session over there. Thank you.